So I'm Andrew Maurer. Nice to meet everybody, by the way. And I'm gonna talk about what I do at Smith College. Let me get my slideshow up here.
Andrew and I have known each other for years. We grew up across the street from each other as very young kids, and so it's cool that we've got similar interests now in adulthood.
Yeah, and live not, like we live really far from where we grew up, but not too far from each other, which is kind of nice.
Yeah, it is.
So, can you all see my screen, first of all?
Yep,
Okay,
absolutely.
cool. So I'm Andrew Maurer. Like I said, my title at Smith College is Interactive Media Coordinator, which means kind of like whatever I want it to mean. So that's kind of nice. I get to play around with lots of cool stuff, and I'll give you some concrete examples of that in just a second. And I hope maybe at the end, I know that we're going to do kind of like a question and answer kind of thing, but I'm hoping maybe to get a little show and tell from you all, because it sounds like you all are really involved in some interesting things. So I'm gonna focus on 3D scanning, and if I do this, can you still see my screen? Yes, okay, cool. And I will cover the basics of a few different kinds of 3D scanning, but the one that we end up using most is photogrammetry, which is just in a nutshell, taking a bunch of photos and then feeding them through specialized software, which effectively looks for similar points from one photo to the next, and then sort of triangulates a 3D mesh out of that. Some of these, okay, we don't need to worry about that. I'm not going to go over this stuff in too much depth, because this slide is actually taken from a workshop where I had people run through photogrammetry. But one thing to remember is that when you're taking a bunch of photos, consistency from one photo to the next is kind of the main key factor that's going to make it most likely that you'll be successful in getting some kind of reasonably good model. I can, if you end up wanting to do this yourself, I'm happy to like share this slideshow with some of these kind of best practices that we've found. One thing is like, if you have a camera that has some sort of manual settings, that's always nice, but you can even get good models like from your phone, I have found. And we've had students who have come, I can show you a few models in a second that I think are really nice that have just been made with somebody's phone camera. And I think that that is one of the main benefits of photogrammetry, is that you can get really nice quality models that like without spending an arm and a leg. The trade-off you make is time. I mean, it takes potentially a long time to make a good photogrammetric model, but again, we'll look at some examples in just a second. I'm just trying to think of any other one other thing is that the lighting of your model ends up getting kind of like baked in. So having even lighting on the thing that you're taking photos of is important. So let's look at kind of the process of going to what lens do I prefer? That's a good question. And thank you for asking the question, because I forgot to mention that I'm happy to be interrupted. You want to, it's not, I mean, it doesn't matter so much what your focal length is. Something like a 10 millimeter would typically be too short, because that would be too wide, and you would end up getting more distortion. So something like a 50 millimeter, yeah, would be kind of more standard. If you have a zoom lens, you want to make sure that you're not changing the focal length and not changing the zoom while you're taking your photos. So we've used all different kinds. If you're doing something really small, sometimes it's good to have like a really long, like macro kind of lens. I think that experimentation is kind of the name of the game a lot of times. And I can run through, I'm not going to run you through the whole process of making a model, but I do have, oops. Here we go. So I'll show you in the photogrammetry software. This is a little gladiator action figure that I've used as a demo. And maybe I'll just jump right in. I think I'm going to need to stop sharing my screen, though, and share my whole screen. So let's do that. OK. So here's my gladiator.
That's neat. Just sitting on an Amazon box.
Yes. And so here's a few things that I want to mention about this. The Amazon box is a strategic thing because it's good to have, if you have an object that's like sitting on a surface, you may have a 3D object that you want to get all the way around. And then in that case, you may rig up something where you sort of are suspending it from a little post or something or hanging it or whatever. But if you have something that sits on the ground, it's good to have some kind of detailed printed image right underneath it that you can track from one photo to the next. So basically that Amazon box is in pretty much every single photo. And that makes it easier for the software to align things. Let me do, if I go up here, turn these on. So this is like all those blue squares represent individual photos. And if I turn on show thumbnails, you can sort of see, like from this view, this is what I was seeing, et cetera, et cetera, et cetera. And you can see that Amazon box is in like all of them. So I'm going to turn that off. Boop. Couple things to mention here. The typical sequence that you go through is you start with a bunch of photos. So you would just drag in like a whole folder of photos. And
Oh,
okay, that's a good question. How are you able to isolate the figure and the box? That is a great question. Well, okay, so I guess I'll ask, would everyone like to see just running through the process here? Because I can do that, and it doesn't take long. Okay, well, why don't we just do that then?
Yeah.
Okay, so I'm gonna.
Could you say something about what the software application is?
Yes, sorry about that. So the software that I'm using is called Metashape, and it used to be called Photoscan. It's made by Agisoft. This is, for my purposes, this is the software that's the best blend of being easy to use, having a pretty good quality output, and also being affordable. There are a couple of other photogrammetry softwares that I would recommend. The one that works the best, in my experience, and is by far the fastest, is called Reality Capture. That one is like, it's like so much faster than other software that you just wonder how it's possible. It's like 10 times faster probably. But so the thing about that is it used to be quite expensive, and now there is there's a pricing model where it's like you license, you pay per photo that you input. So you're able now to sort of pay on a per project basis, which I think actually makes sense. And so I haven't actually revisited that software since they started using that model, but I know that when I was testing it, this was like probably a couple of years ago at this point, it was just like crazy fast and crazy good quality. But that being said, Metashape and pretty much any other photogrammetry software, given good enough photos, will give you a pretty good result. And that's kind of the thing, is like the result that you get is always dependent on the quality of your inputs. So you do want to take the time when you're taking the photos to make sure that you are getting good photos. Yeah, So that being said, when I open my folder of photos, you can see here are some of them. The first step in Metashape that I run, and this is a nice thing in Metashape, is that under this workflow menu is all the steps you need to do like in order, which I like a lot. So I would have gone to, well, heck, let's just I do want to do that, but let's just open up this project. I'm going to add the folder here. Sorry, I'm gonna. Let me see. Oh, that's what I wanted. Okay, cool. So that's just all of my Gladiator photos. And you can see right now they say NA because they're not aligned. Under the workflow menu, I go to align photos. The settings here, right now I have them set just so this all goes really fast. But all of these are things that can be tweaked to improve either improve performance or improve quality, basically. But I'm also on a computer with a really good graphics card, and the processing is being done on the graphics card. So this is going pretty substantially faster than you might end up getting like on a laptop or something. Yeah, to somebody's comment in the chat, this software is great too because it is Windows, Mac, and Linux, which is always the case. Okay, so it's run through that, and now I've got, this is what you would call a sparse point cloud. So this is kind of the first run through. And if I was gonna really do things right, I would probably create a dense point cloud from this, but I'm not gonna do that because it's not necessary. It would just give you basically do a second pass and give you a more accurate model. But what I will do is, one complaint that I have with Metashape is that the interface is a little bit clunky, but in order to change this bounding box for what ends up getting processed, you sort of have to just like, I don't know, fiddle around with like moving back and forth between these different tools. I think that the pro version might be a little bit more elegant, but in any case, in answer to the question of how to set your bounding region, this is how you do it. And it's good to do this kind of early in the process, because anything that's outside of this region, the software won't bother taking the time to calculate. So you can save some time this way. Doing this. And okay, I don't know, that's probably fine. We might be a little cutting off his hand there, but who cares? Zoom in. Next step, normally I would do the build dense cloud option here, but I'm not going to do that. And instead I'm going to go to build mesh. And again, these settings are set for speed rather than quality, just an FYI.
Yeah, it's neat to see all those little points. And I'm imagining that somewhere deep inside, it's building triangles out of those points to try and build a mesh.
Yes, that is exactly what it's doing at this point.
Cool. Yeah, because do you find with software like this, is it good at giving you things that spill out and are 3D printable if you wanted to?
Well, that's a great question. And I can show you in just a second the software that I normally use to get things to be, well, so short answer to that question is no. Almost any 3D scan is going to be incredibly messy data, and when it comes out of the software initially, it probably will not be 3D printable. You know, some photogrammetry software might have some kind of functions built in to make things watertight and this kind of thing. But the software that I use and recommend to students and stuff is Meshmixer, which is free and just crazily powerful and does things that, again, you just wonder, like, how does this one software do this thing so well that other software can't do? But it's sort of some kind of a cult situation, I think, maybe. Yeah, Meshmixer is free, and it is for, I believe it's also Windows, Mac, and Linux. It's at least Windows and Mac. Okay, so we've got now, yes, our 3D model that was generated here. And you can see there's a little bit of funkiness happening. Like this guy has a sword that has gotten a little bit screwed up. He's also got this little extra bit of arm where it's kind of like a little waddle down here. It kind of misinterpreted the edge. There's something happening with the distinction between his arm and the background that it got a little hung up on. But overall, I would say this is pretty good. And you know, as these things go, this is a pretty low resolution scan. You could get a much higher quality scan if you took longer to process it. Also, if you used the highest resolution photos possible, that kind of thing. But one point to make, I think that it sounds like everybody in here is probably most interested in 3D scanning as a way to get physical output. But if you're using it for on-screen purposes, like graphical purposes, it's always good to remember that what a model looks like on screen is a combination of the geometric detail to some extent, so like the triangles that compose it, but then also of the photographic texture that gets wrapped around it. And that being said, I'll run kind of one final step here.
Cool. Yeah, I'd say there's a broad interest from people at MakeHaven. Some people would definitely be interested in there's somebody who is making VR games. There's people who do all sorts of stuff. So it would be neat to see all sorts of different roles. And man, that looks great just with the texture.
Yeah, doesn't that look great? And all of a sudden, I mean, the thing that looked a little bit kind of blocky like this, all of a sudden when you put that photo texture on, becomes this really kind of amazing thing. So that is one thing that photogrammetry excels at, is obviously, since it's composed of photographs, it gives you a really nice photo texture laid over the thing. And I'll show you some examples. That's good to know that there's a variety of interests, because I've got examples of some kind of, this stuff being used in lots of different ways. So yes, JR said MeshLab is another alternative to Meshmixer. And that is, yes, that is one that is a lot more, if you're wired a certain way, you probably would prefer one or the other. Meshmixer is a bit more like gloopy, you know what I mean? It's just a bit more like hands-on. And MeshLab is a bit more procedural. It's like run this function, run this function. So either, yeah, and both ways work equally well. So let's jump right into Meshmixer, I guess, because I did bring this thing in here. I can get rid of that, but I had been thinking that it might be good to show you, just kind of like if you did want to 3D print. I'm just gonna move back. I don't even know what I was doing here, but so Meshmixer, so this is my 3D scan. I exported it from Metashape over here. And I did sort of discard the color texture because in this case, I mean, we don't have any like, gypsum based printers, or like, we don't have like a color 3D printer. All of ours are plastic and one color. So I just get rid of the color information. But there's some stuff that Meshmixer makes it really easy to do. One thing that you'll often find with a 3D print is like you have extraneous material or you have holes and stuff. So this just makes it really easy to get rid of stuff that you don't want. And then it's got a whole suite of features for dealing with errors in your mesh. In this case, I just want to fill this hole in because for something to be 3D printable, it needs to be watertight. And so you can see made it pretty easy. I just had to like hit one keyboard key and it sort of created this nice smooth, it sort of tries to estimate, what the edge shape is supposed to be. Meshmixer is also good. Another common thing you have to do when you bring a thing out of photogrammetry software or any kind of 3D scan is that it might be oriented incorrectly. So this allows you to set it up upright, scale it, and do all that basic stuff. It also is good if you want to do silly things like add different parts of different models together. So if this guy needed to have like some kind of duck head coming out of him, whoops, I'm flipping it inside out there. There we go, there we go. Let's move it over there. So this is kind of entertaining, but this is just like a default thing that comes with Meshmixer, but anything that you have from a 3D scan can be turned into kind of a Meshmixer object like this and just sort of grafted on to something else. And it's pretty nutso because it actually like, it's not just like what you would call a Boolean operation where you have a thing and another thing and then you just sort of put them together and then you say wherever you just like put them together based on what their shapes already are. This actually like sort of interpolates between the shapes. So you have like these smooth boundaries from the swan head to the shoulder here. And so I don't know how it does that. I don't know, math, I guess. But so yeah, so Meshmixer, it can be fun, and it's got, in addition to the sort of functional stuff for dealing with 3D scans like this, it's got all these sculpting tools built in also, so you can tweak things. Somebody mentioned that they were a sculptor interested in kind of transitioning into digital stuff, and there's other software that does this, but Meshmixer is one that I found to be pretty good. I'm just gonna, whatever, I don't know. I don't really need to do that, but I was just trying to think of like, if I wanted to, let's say I just wanted to make this look more like a hand or something instead of this like lump where a sword got cut off. Meshmixer's got all kinds of crazy sculpting brushes and things. Maybe I would use the Flattened Brush. And one thing that it does is if you want it to, and this is like another kind of thing that's unique to Meshmixer, if you want it to, right now I'm not actually creating any new geometry, but if you want it to, it will automatically like add or remove triangles from the mesh, like based on how much detail it thinks it needs there. So that's kind of a really nice thing. I guess I won't go into this too much, but anyway, Meshmixer is, I would recommend as sort of a general purpose. I think they call it sort of a Swiss Army knife for 3D scans. And I found that to be true. I mean, it comes in handy in a lot of situations.
Looks like it's going to be an ice cream cone.
Yeah, I like it. Maybe we could, actually, maybe we could amp that up a little bit with one of these, the Inflate Brush. I have enable refinement on, so it'll make new triangles. Oh, there we go. Yeah, that's like
That's definitely an ice cream cone.
melting already. You could give it 3 scoops here, maybe. I don't know.
Yeah, that seems nice.
Yeah. So you can see this is really fun and intuitive. If you have like a Wacom tablet or, you know, I suppose like a touch screen would be good too, but I've never tried it. Yeah, this can be a good way to go.
What file type is this when you save it?
So this has its own native file type called .mix, but it exports to a number of standard formats. We usually end up using OBJ, but it also does STLs, which is you know, common for 3D printing. Yeah. He turned from a warrior into just like, yeah, everybody's favorite friend. I don't know, the guy with ice cream. So these are the formats that it uses. It's a pretty broad variety for different applications. But yeah, we end up using OBJ pretty exclusively.
Cool.
Yeah.
It seems like you've got lots of options there. So you've scanned this guy, you've imported him into Meshmaker, and then let's see what's next.
So if you're gonna 3D print, you could continue cleaning this up and export from here to an OBJ or an STL.
Yep.
I won't go over that process, but let me jump back in. So maybe I can go over a few examples. So where I am at Smith, I work, our department's technically within the art department, and I have a background in art, and a lot of the scans and things that we do end up being for, like we do some scans of things from the Smith College Museum of Art. We've done projects with different departments, but they're sort of cultural objects and objects of study in various ways. So I think maybe I'll just show a few examples of that kind of stuff. This thing is an example of photogrammetry that is, this thing in real life is like, you know, this big. It's like a walnut. It's a rosary bead that has this crazily intricate detailed carving on it. And sorry, I'm getting a little funky with the scrolling, but you can see in here this sort of scene at an altar, and it's a pretty fascinating object inside and outside.
Wow.
Yeah.
Is it Italian
I think it's
or German?
Dutch. I think it's, yeah, it's northern something or other. I think it's,
Wow.
That's
I probably wrote it in. It's from a workshop in the southern Netherlands.
Oh, I see.
And in this case, just a technical note on this, this was made from a lot of photographs, and it was made in 2 halves. One of them was with this upright, and then the other was sort of flipped over. And this was like, with stuff like this, it's kind of funny because, you know, the people at the art museum have to, like, I'm not allowed to touch it. So I'm having to ask them to move things in all these funny ways. I think that where was that? Oh, I do have an image up here. These are just the examples of photos from that session. And I ended up in that case taking these into Maya to add a little bit of animation, because this was like an object that it made sense to show in a couple of different states. So, and I'll jump into Maya in a minute. I don't have really a huge project to show you in Maya, but I can at least show you the interface and show you the basics of how it works.
Sure. Yeah.
Let me see. So I showed you the rosary bead. We have some other objects from the Smith College Museum of Art. And I thought the one interesting kind of use case for 3D scanning and printing was this over here is a photo of a class where we have a collection of Greek objects at Smith, and they scanned these cups, and then we 3D printed them, and then they used them in a recreation of the way that they would have been used. So they, I guess it was a Greek symposium involved, like while you were holding the cup, you had to be telling some fantastic tale, and then you were judged on your oratory. So basically, I thought it was nice, just a nice use case where sort of it made sense to kind of make a 3D print for this classics course. Another way that we have used photogrammetry and 3D scanning is, this is an example, and it's not, these pictures are hard to tell, but these are actually photogrammetric scans of a site in the woods that was like an old homestead. And so our idea with this, and this is sort of in a prototype state, but our idea with this is like, we have scans taken of this site at different time, like one, I think is like 6 months after the other one. And so I put together like a sort of simple VR prototype where you're standing in this space at 1-to-1 scale, but you can switch between time periods. So you could potentially observe changes in a site over time. And I think I do have Brink. Whoops. I'm just gonna skip ahead here. There's just like a brief flash of that, but this is that actual model.
Wow.
That is pretty expansive.
It is, and it's kind of amazing how it works too, because it's just it's the same photogrammetry process as you would use taking pictures of a small object. You're just kind of moving around this space and taking more photos. And you know, sometimes I think that in the case of that space in the woods, I think a drone might have been sort of difficult, but drone photogrammetry is a way that people tend to take to make really large scans, basically.
Oh, that's what I was going to ask, is drones. Yeah.
Yeah. At Smith, it's kind of funny because the people who do the drone photogrammetry, that's like a whole separate department from, but it's just the nature of institutions, I guess. Any questions about anything so far?
No, it's been really cool to see this done on several different scales. Is there anything within the photogrammetry space that you're really excited about? Things that look like they're on the horizon that are coming up?
Well, I mean, I don't know how exciting this is, but just the speed continues to increase. Things just seem to be getting more efficient, and that's kind of nice. And it seems like algorithms are getting more efficient, and you know, we're not. The nice thing about photogrammetry is that you don't need super specialized hardware to do it. I mean, it goes faster, like the faster your computer is, but I guess that is one thing I like about it. I just like the fact that it's sort of, it's very DIY. Like you can just do it at home. Like I said, you can use your phone camera. I mean, that's super cool to me.
Oh, I actually have a question.
Yeah.
Have you heard anything about being able to use LiDAR in with 3D scanning? Because I know that, like the new iPhones have it and it's kind of emerging.
Yes. I don't know much about it, but I know that um, it's supposed. I mean, yeah, I think that's part of the whole idea is that it can give you much like more accurate 3D scans, like in the palm of your hand, which is way cool, and it's cool to see the companies going in that direction.
Mm.
We have sort of along those same lines, and somebody mentioned the scanning with the Xbox Connect. This here thing is the structure sensor scanner. And it attaches to an iPad, as you can see, and it gives you pretty darn good quality scans. They're not as good as you get with photogrammetry in terms of detail or photo resolution, but on the other hand, making a scan with this takes about 5 minutes, as opposed to the time that it takes to set up your workspace and take the photos and transfer them to your computer and process the scans and clean it up, blah, 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 blah. So, I mean, I'm always kind of thinking about like best bang for your buck. And this one, I think this scanner is like maybe $300 or $400. Obviously, you have to have the iPad to go with it, but it's really not a bad deal. And this is the one that we end up giving. We loan these out to students because they're straightforward enough that you can work on
And
your
what
own.
is its output? Does it give you an OBJ or an STL or
It
something
gives
at
you
the
an
end?
OBJ.
An OBJ, okay.
Yeah.
Well, they also offer a service where you send them your scan and they model it or something, I think.
Oh, cleanup.
Yeah.
They do. Yeah, they've got the Canvas app where you can they'll like generate plan, like say you take some scans of rooms in your house, they'll like generate plans from those. I think is one thing that they'll do.
Mm. Interesting.
Yeah. So maybe I'll show a couple of examples of like one thing that I end up doing a lot in our sphere at the art department at Smith is we're kind of in the business of making like virtual galleries, and sometimes that will include 3D scanned objects.
Hey, I have a quick question.
Yeah.
Does this software require a high-end graphics card in, oops, siren going off here. A high-end graphics card in your computer?
So it does not. It's optimized to work best. I mean, it'll go faster if you have a high-end graphics card, but it'll totally run. Like Metashape will totally run without a super beefy computer. And that holds true, I find, of a lot of 3D software. I mean, things will run more smoothly if you have a higher end computer, but it really doesn't take too much just to get it to run if you're willing to kind of put up with the speed maybe being a little slower. So this is an example of, this is a model of our main gallery space at Smith, and this is a very rough prototype. I can show you a slightly more finished thing in a minute, but this is just like a VR thing I set up. This is one of the scans that we made from the art museum, and it's like I think in a minute I pick up that vase and throw it over across the room, which is kind of fun. But this is an example of like an application that there might be for 3D scanned objects. So this is sort of a thing where you can plan an exhibition. You can, you can.
It's a priceless antique. What do you?
I know, but somehow it's pretty durable, surprisingly. And this is done in Unity, which I end up using a lot for making interactive stuff. And I'll show you another example too of that same model. But so this is the same gallery model, but just with a bit more of a fleshed out exhibition in it. And I guess I wanted to point out, let's see, is this gonna go? It's gonna go. Yeah. Okay. Cool. This was our senior student exhibition from last semester, because they wanted to have to work out the logistics of putting it in the actual physical gallery space, but they weren't on campus. They were all over the country. So I worked with them and we put it together in this scale model. The exhibition is called Unsaved Changes Will Be Lost, and they wanted sort of like a Windows 95 theme. So you'll see in a second when things pop up, they have sort of Windows 95 menu bars, which is really apropos of nothing other than that it was entertaining for me to do that. So you can see here what this is the student who made this lamp, this paper lamp, and then she just took all the photos to make a scan of it herself, like a 3D scan. And when you click on it, you then have other sort of like reference images. It would have been nice with something like this to take the time to actually make it sort of look lit up in the virtual space, which is totally possible. But just another level of complexity that we didn't feel was important enough. But you can see in this particular gallery, most of these things on the walls are flat. And in general, it sort of adds another layer of complexity to have. Like the more 3D scans we bring in, the more little tweaky things there are to do. But one thing that I have learned, if you ever happen to find yourself in the position of putting together a 3D virtual gallery show, one thing that I have learned is that images on a wall look much more normal if they have some kind of 3D frame around them to make them into an object. If they don't, they're kind of just weird and floaty. It's just sort of a weird perceptual thing that you wouldn't even think about, but there's a free tip for the next interactive 3D virtual gallery you need to make. And that's something that we, there we go, have ended up doing quite a bit at Smith. I think it'd be fun, for me, it'd be fun to start to get more into, rather than just making a thing that sort of emulates a physical space, to get people thinking more about, okay, what can you do in a virtual space that you can't do in a physical space, or what are the different kinds of ways of interacting with things, or turning things into a bit more of a game, potentially. So those are all the kinds of possibilities that arise. Yeah, that's kind of the general idea with the virtual galleries. I did want to mention a couple things. Now this is back to kind of the technical stuff about photogrammetry. Sketchfab is going to be your best option for sharing 3D scans. It's kind of the only game in town. There are other services, but there kind of aren't. Sketchfab is like the YouTube of 3D scans, basically. So just wanted to mention that, and it's free. It's also a good place to like search if you are thinking about making a 3D scan. It's not unlikely that somebody else maybe already has made a 3D scan of that thing. So it's a good place to search for that, as are other things like Thingiverse or GrabCAD or some of those kinds of places. Couple of disclaimers about photogrammetry is that it's really not very good at certain kinds of objects. Anything shiny or transparent, it's not going to get, because anything that sort of changes what it looks like as you move around it, because it reflects light, is going to be a little bit iffy.
Can I ask you a question about that?
Yeah.
If you have something that is reflective or transparent, if you're able, I mean, obviously you can't with a lot of these things, but if you were able to like dust it with something like a powder, will that give it enough to?
Yes,
Okay.
that will definitely help.
Just to get the shape, because
If
then you'd
as
have
long
to
as
go
all you
back.
want is the shape, yeah,
Right.
yeah.
Cool.
Good question.
And they make these little like powder pen thing. Well, they make a spray actually. You can get like a powder spray stuff, and then there's also this like kind of pen thing that has powder that poofs out of it that you can use. That works pretty well.
Do you ever do editing of UV maps? Like open them in Photoshop and mess with them or something?
Yeah. So I can. Why don't I jump over into Maya, and we can look at that. Quick disclaimer here: this is not pre-planned at all, so I'm just going to try to pull in something that maybe will look interesting. I'll see if I can grab that gladiator.
Also, I have a 7 o'clock appointment, so I'll be bowing out for that right about 7 o'clock.
Okay.
All right. See ya. One of the things that's neat, and you keep going with what you're doing, Andrew. I'm just going to talk a little bit. The people in the foundations class have been focused a lot on sketch and extrude style modeling, which you might do for engineering kind of purposes. Whereas Maya is really neat because it definitely feels like it's got more of an artist focus, more the like squishy kind of 3D modeling.
Right. Same of Blender too.
Yeah.
Yeah, Maya and Blender are pretty equivalent, and they're often used for 3D graphics, for character modeling, for games and animation and things like that. And they give you a lot of control over the kinds of shapes that you're able to create. At the expense though of complexity, because they're not very beginner friendly. And I know personally I've learned Maya and I don't ever plan to learn anything else because it's just such a time investment. It's like but my little guy came in here really small. But I thought, let's see. I mean, there's all kinds of crazy modeling tools and stuff in Maya. And Maya is actually best suited for what you would call cleaner geometry. In this case, all these triangles are kind of irregular. And if you were to try to, say, bend parts of this to animate it or things like that, it might get a little funky looking. But I guess one thing that could be interesting is, okay, so I turn on the texture there. And if I go to my UV editor.
Okay. It's in Maya.
Well, so yeah, you can see these are the shells, the different shells of the model, and they're so dense that it's kind of hard to see, but you can see that basically the square here is just the image texture, and then whatever, you can visually change how things are mapped. I'm going to do something really grotesque for a minute. But if we look at, let's see here, I don't want to do that. Yeah, there we go. If you look at this fella's face here, if I grab this UV shell, I can transform it, scale it, and you can see that everything's getting all squishy and weird over there. But this is what you would want to do if things weren't correct. You could match things up this way. And there's sort of a whole science, well, more of an art, I guess, to UV mapping. And it's kind of the part of the process of creating a 3D model. Most typically, things like Maya and Blender are used to create something from scratch. So where you would be starting with primitive shapes and making them more and more complex until you turn them in. It's like starting with a box and then making it into a gladiator, 20 steps down the line. But they also can come in handy for tweaking 3D scanned models. And the other thing that is good to keep in mind about image textures is that they are in fact just images. And so you can go into Photoshop and sharpen them, increase the contrast. Anything you can do to an image will show up on your model.
You could paint on it and stuff. Yeah.
Yeah, absolutely. And it does become a little complicated if you look at the UVs again. Like this thing, because it was from a 3D scan, there's really no logic to the way that all these different flattened out parts are laid out. So it becomes a little bit complicated to, if you were going to paint on it, there might be parts where like you would get to an edge and it's like part of the face is actually over here or something like that, if that makes sense. So that's just something to think about.
Wow.
And
A bunch of gum wrappers you threw out and unraveled.
Yeah. Oh, there was a question. Have you played with the 3D parts of Photoshop, Andrew?
I have a little bit, yeah. And as I recall, you can use 3D models to, you can render them in images, but which can be useful, although you can't actually modify the models themselves in Photoshop, as I recall. But you still can, I mean, obviously you can edit any image that is attached to a 3D model in Photoshop.
Cool.
Cool. Any other questions about Maya or Photoshop or any other software that people are interested in? I'm just like, I think I'm pretty much, I've pretty much shared the basics of what I was planning to in a little bit of a roundabout way. So
I could show you Match Photo and SketchUp if you want to see it. If you can share my screen at all.
Thank you. Bye.
Okay.
See you, Rich.
Bye.
Thanks. Yeah, there's tons of cool stuff. How about other let's see, while we're cruising around doing anything. Andrew, what are other so have you played with LiDAR, things beyond structured light scanning? Have you done much of that ever?
Yeah, good question. So the scanner that we have at Smith that's like sort of better quality is a Next Engine laser scanner, which is like a structured light scanner where it projects laser beams on a thing, and then it's got some cameras that are measuring the deformation of the lasers over the thing. And in fact, I think maybe that's what's at the beginning of this video. So it's doing this, and then
oh yeah, that's like the in a movie laser scanning.
I know,
right? Like,
yeah, it's like super high tech and cool looking.
yeah.
And then it gives you, this is an example of the surface quality that gives you, which is quite good. I mean, it's down to like sub-millimeter kind of resolution. But that one it's quite labor intensive, and it takes a long time because you're making multiple scans from multiple angles and then stitching them together in software. The scanners that make me drool are the Artec scanners that are handheld, and that it's sort of like the ease of use of this thing effectively, but with the quality of photogrammetry, like more like higher quality even than photogrammetry. But you end up paying $20,000 plus for that. So
yeah,
that's the trade-off. Yeah.
like buying a car.
Yeah. So those are the ones that I am most familiar with. And then there are also even crazier scanners that they use. It's like, I think they're called blue light scanners, and I don't even know what that means. I said it like I knew what it meant, but it's like some kind of technology where you can even scan things that are effectively like transparent or super glossy, or and I've used one that was sort of, it was a Faro brand, I believe. It was like, it's like connected to kind of an arm, and it's like as you move the arm, it's like there are sensors in the arm detecting how the arm is moving, and that factors into how the thing is reconstructed.
Gotcha.
Yeah.
Yeah, that makes some sense. You could do the math backwards for the geometry position of the camera.
Yeah, exactly.
If you, lots of materials are transparent or not in different colors of light. So maybe the blue light, they're hoping to hit something transparent with a color of light, a wavelength of light that it would bounce off of it instead of go through it.
That makes sense. Yeah.
Yeah.
Kate asked about a favorite setup for shooting the initial photos for photogrammetry. And the main considerations for me are like having something with some detail flat under the thing. And trying to be in a place where there's not a lot moving in the background, because anything that moves in the background that's inconsistent, like from one photo to the next, like anything where the relationship between it and the other things in the scene is inconsistent from one photo to the next, that's going to confuse the software. I usually just set stuff on a table in like a small room.
I'm imagining, like, I think that we have one of those turntable deals. If you had a light box and a turntable and then like it was sitting on gift wrap paper or something so that it had a texture that it was sitting on, would that possibly work?
So if the thing is going to be, yeah, as long as the paper's on the turntable.
Yeah. Yes.
Yeah.
Is it better to use like an irregular image, like print, instead of something that's super geometric? Does that throw it off?
It is, yeah. Like a really even grid would confuse it. Something that's irregular is better. Yeah.
Gotcha.
And one thing that we have used with some success is this little thing is like a light tent we got on Amazon for like 20 bucks. And you just, basically it's kind of like a sheer fabric. So the light goes through it and gets really diffused. And it's like the light can go through it, but it also bounces around inside of this box. So it tends to eliminate harsh shadows. So if you're doing, in that case, if you're moving the turntable instead of moving around the object, it's good to have like as few shadows as possible.
Gotcha.
Yeah.
Do you have any, say for instance, you were trying to get a copy of something that's very small and also monochromatic. How would you go about that? Are there any tips or pitfalls? Because I have had some very frustrating experiences.
How small is small?
Like about the size of your walnut, probably.
Yeah, so you will probably want to use some, like probably the issue there is, well, there could be multiple issues, but something, you kind of always want to fill as much of the frame of your shot as possible with the object. And the smaller the object is, the closer that means you have to be to it, and the less likely it is that you're actually going to be able to focus.
Oh, and then distortion.
And then,
right.
Exactly, a distortion can come into play too.
So you'd have to like use a telephoto and back up and zoom
so
in.
If you had like, if you had like kind of a longish lens,
I mean, I can show you an example of the kind of stuff I might need to do.
Yeah.
Like this is a little monster head, but it's like, it's small. So it's angry. So this is like a part of a model kit, and it's in a matte gray wax.
Yes.
So this is sort of what I'm doing. Like, would it be like, would I want to dust it or do anything to it to maximize the potential for success, I guess?
I would think so. That kind of object would actually be perfect for the kind of like laser scanner thing that I was describing, because it's already like a flat color and the details are so small. But I don't think that you would really be that much farther ahead by dusting that, than you would just by taking the photos as it is, because this surface is already kind of similar, in that it's matte and one color. Yeah.
We got a question about the macro lens. If you were trying to take a lens for photo.
Yes. So it doesn't. I remember we have like 100mm lens that we have used. I'm trying to remember. There were some issues. The thing you end up encountering is it's really easy to, yeah. So I can't, off the top of my head, I don't know exactly what settings you would want to use. However, you are going to want to get an extremely like deep depth of focus, which is going to be a larger f-stop, smaller aperture, like a larger number, smaller hole. And that's going to mean you definitely are going to, you can't handhold. You'll definitely have to have it on a tripod, and you'll want to use like a if it's possible to use like a remote shutter release, so you're not shaking the camera. So you want as much of the photo to be in focus as possible. With a macro lens, it's really easy to have, like, even with a tiny little object, you know, one sort of plane of it in focus and then the rest of it blurry or something. That's what you want to try to avoid. Let's see.
Cool. Well, I just keeping track of time, strictly that. We're at 7:10. So you've been going for a little bit, Andrew.
Yeah, yeah. It sort of time flew by.
Yeah, it sure did. It's neat. You're clearly very knowledgeable. It's been awesome. I want to make sure that we're respecting your time. We're very thankful that you arranged to come in and chat.
Yeah, happy to do it. This is really fun.
Yeah. And so it'd be, if you want to keep chatting, to look at things, talk about whatever, answer questions, we sure can. I also, you know, you very likely have things that you need to do. So just wanted to.
Well, it is COVID. I don't
know. I'm sorry. I actually have to take off, but thank you so much, Andrew. This was really,
absolutely.
really
I think if
helpful.
everybody planned on this it being an hour, then let's just say we're done.
Sure. Yeah.
Thank you.
Robert,
Take care.
you had some things that you wanted to check out too. Was it?
If you want to take a quick look, let's see if I can.
Yeah, sure. I can stop sharing.
See, Jamie.
Let's see if this. So you should be seeing a window from SketchUp here.
Yes.
Oh, is this like so you took a picture and then you're drawing it from there?
Yeah, this is a photograph, and I'm using let's see if I'm in SketchUp, then we can pull it out of the photograph. So this is it after modeling it.
Oh, that's cool.
This is so you can take multiple pictures and try to sync them. It uses rules of perspective to this is you know, in the match photo mode, there is an origin and you try and match up parallel lines. We go to the other view.
Cool.
So we find some things that are parallel lines that will find the vanishing points and so on. So it is definitely SketchUp, unlike Maya or Blender. SketchUp is all sort of best at very rectilinear things, but that works well with buildings like this. So and then you can project photographs. You can project the texture from the photograph onto the object, and that's how you get some bizarre things like this railing running across the front of the building. You need another photograph to do a better job of that. But for quick and dirty, it works pretty well at helping me. I just need a next door neighbor's house as context for my project. It doesn't need to be too excellent, but it's a pretty neat tool. And I think it was partly for a while, Google owned SketchUp, and I think they did that, and they gave away the software for free, which is now that Google sold it off to Trimble. Trimble's like, we're not giving it away for free anymore. But when Google had it, I think their idea was they would use this like Wikipedia and get everybody to use Match Photo to build the buildings in their neighborhood and populate Google Earth with the buildings. And I guess they decided they had better technology and would abandon that cause. But that's kind of where this came from. But it's a neat technique, and it helps to have some knowledge of perspective when you work with it.
Yeah, and Andrew, it sounded like you said you have students that do similar things for when they're making models and designs, where they take like 1 or 2 photos and they go from there. It was
Yeah.
right at the beginning. Or maybe like if you're modeling in Maya, you use photos for inspiration of the geometry of what you'd be modeling.
Yeah, we do a lot of that with like using reference photos and setting them up on like 2 planes maybe. Yeah.
That makes sense.
Yeah.
Yeah, that's really neat. Yeah, I think that actually Google has switched over to use photogrammetry for Google Maps.
Yeah.
I think that they do flyovers of major cities, and they use that to build out, because I was Googling it before this last round of, I was searching to see how they do it. And I believe they use photogrammetry to figure.
It's kind of a melted cake of sorts when you look at things closely.
Yeah.
Okay.
Yeah, Kate, I was Googling about Google. You got it.
Whoa.
The SketchUp Make 2017 was the last free version, and they still offer it for free if you know where to go download it. They kind of hide the page with all the downloads on it, but the last time I taught SketchUp for 6 years at a private high school in Danbury, and the last class I taught Match Photo, and we had to install SketchUp Make in order to teach the class. There are they now give away as a free version for SketchUp web-based versions, and the web-based version does not do Match Photo. You have to have a desktop version.
Yeah, I think the web version doesn't really like export anything either.
Yeah, it's quite crippled. There's no plugins, and it depends on whether the free version does very little. If you pay them money, you can get SketchUp Shop, which does a few more things like export DWG, I think, but not for free.
Yeah, it seems like the world kind of knows that 3D content is going to be on the rise and a hot commodity very soon. So I feel like all of these 3D scanning apps, they like somehow disappear into a paid space after they may have been free for a couple of years.
Yeah,
There was a lot of Autodesk stuff that was like that for a while it was free, and then they wrapped it into their paid products that are like very paid. I mean,
yes. Yeah, so SketchUp is going that way, and there's a lot of rumbling of mutiny amongst some of the users. People are saying, we're leaving this for Blender. I'm not seeing, some people are doing architecture with Blender, but it's not really built for it that well. But and as you said, learning one program, I've invested 18 years in learning SketchUp, and it's like, am I going to throw it away and learn something new all over again?
They got you hooked. Yeah.
Yep. Yeah, it definitely takes some time.
Yeah.
Cool. Yeah, I feel like we've really covered a lot of bases here on how to do photogrammetry, how to do like other interesting processes. I would love to get to play with one of those laser scanners because it feels like the future.
Yeah.
And
2018 convention for SketchUp, I did go to a seminar. It was all the way out in Palm Springs. I went to a seminar on an outfit that uses those $20,000 laser scanners to do buildings and stuff like that. And the engineering firm that does that was from Springfield, Massachusetts. They're called Stangl Associates, but it was like quite cool. But all the hardware is in that $20,000 range.
Yeah. Yeah.
It's cool.
You probably cross over into higher end optics, higher end all that business. So
Yeah.
Yeah. Well, and actually a lot of, at least with those 3D scanners I was talking about, a lot of it's in the software, actually. It's like there's proprietary software that goes with it, and you do the thing with the little magic wand, but then the processing happens in the software. And a lot of the quality is coming from the way that all that raw data is being processed.
yeah, that's fascinating.
Okay.
All right. Perhaps we should call it. And Andrew, I definitely owe you a drink next time I see you.
Hey, I'll take you up on that. Okay. This is really fun. Thank you so much for inviting me,
Yeah.
and thanks everybody
Thank you.
Yeah,
for here.
absolutely.
Yeah.
All
Thank
right.
you very much. Have a great night.
Okay.
Bye.